Hey friends. So today is actually our last lesson in quadratics. Okay, we're all the way up to lesson 11. Just as a quick recap, we kind of divided this unit into two different sections. Okay, so the first half dealt with quadratic functions. And then we kind of ended our quadratic functions with a lesson on applications of quadratic functions. Then we switched into quadratic equations, and now we're going to end the quadratic equation section with a conversation around applications. Okay. So you're going to see lots of similar things, and in a lot of respects, there's nothing new today. It's just a matter of taking the information we need out of a word problem and then doing everything you've come to know and love with quadratics from the stuff you took out of the word problem. Okay, so we got this, we can do this. Okay, here's our first one. An arch over a bridge is constructed with two metal arcs. The function that describes the arch is h of d equals negative 0.005061 d squared plus 0.499015d, where h of d is the height in meters of the arch above the bridge, and d is the distance in meters from one end of the bridge. I'm just going to hide myself for those of you who need to see the full question there. Okay, and I'm going to make that question a little smaller as we talk about the two parts that we actually have to answer. So the first part is algebraically determine the distance between the bases of the arch. Okay, so I'm essentially looking, if I can just get my ink on here, I'm essentially looking for this distance here from there to there, which will be told to me with that x-intercept, right? If I start at 0, 0, then whatever this x-intercept is, say that was 10, 0, then I would know, oh, it's 10 meters wide because I go from 0 to 10. That's a distance of 10. Okay. Okay, so we're going to do this algebraically, and so we're going to try and factor first. You always would want to try and factor before you do anything else when it comes to quadratics. Now, I have a greatest common factor here of d. Okay, so I can actually just take the d out. Now, my front term is negative, so I'm also going to take out the negative d, not just d. Okay, so I set it equal to 0 because I'm solving for the x-intercept. When I'm solving for the x-intercept, the y value is 0. And then I factored out the negative d. So if I factored out the negative d, I'll get negative d bracket 0.005061d minus 0.499015. Now, that is the zero product principle. Okay, so either my 0 comes from this guy or my 0 comes from that guy. That's the product. I have negative d times something else. Okay, so either negative d equals 0, which would cause a conclusion of d equals 0, and we already knew that, right? Because my vertex was, or sorry, not my vertex, but my starting point was at 0, 0. Or the 0.005061d minus 0.499015 could be my other 0, and that's the one I'm actually want to pay attention to, right? Okay, so the first one's done. I know that 0 equals d. I just multiply both sides by negative 1. And then for this guy, I'm going to need to essentially add 0.499015 to both sides. And then I can divide by 0.005061. Okay, that's going to give me d is 98.6. So if this here is 98.6 comma 0, what that tells me is the distance between the bases is 98.6 meters. Okay, so then I would just do a concluding sentence. The distance between the two bases is 98.6 meters. Perfect. Okay, now question number 2 with this scenario, determine the maximum height of the arch. Okay, to get the maximum height, I would need the vertex. Now, this is not in vertex form, but I now know the two x-intercepts. So that's enough information for me to take the average of those two x-intercepts, and that will give me the axis of symmetry. The axis of symmetry is the x value of my vertex. Therefore, I can plug that into the original equation and get my y value out. So axis of symmetry ends up being 0 plus 98.6 divided by 2, and that's going to give me 49.3, okay? Plug that into the original equation, so I'm looking at f of 49.3. So everywhere where I saw d, I'm plugging in 49.3. Throw that in your calculator, and you get 12.3. So that tells us that the maximum height of the arch is 12.3 meters, okay? Awesome. Okay, let's take a look at the next one here. I'm just going to hide myself for a quick sec. Determine 3 consecutive odd integers if the square of the largest integer is 33 less than the sum of the squares of the 2 smaller integers. Okay, so odd, like my mama told me I was, means not even. So 1, 3, 5 would be consecutive odd. Consecutive means one right after the other, okay? So consecutive odd after 3 would be 5. Consecutive odd after 11 would be 13, okay? Now, when we do this, we have to make sure our numbers are actually odd. And the way we make sure our number is odd is we pick a variable, a, b, n, x, doesn't matter, and we multiply that variable by 2. As soon as you multiply by 2, you are guaranteed that variable is even. So then you would either add 1 or subtract 1, and that would guarantee that you're odd. Okay, so what I'm going to do is I'm going to call my odd numbers 2x plus 1, and then 2x plus 3, and then 2x plus 5. Okay, because you're always 2 away from the next odd number. Okay, now I have to come up with the equation. So it says the larger integer, well, the larger integer would be this guy here, 2x plus 5, right? So it says the square of the largest integer, so I'm going to have to square that, okay, is, well, usually with is, I'm going to have an equal sign, okay? So then it's 33 less than the sum of the squares of the other 2. So I'm going to square each of the other 2, add them together, but then it's 33 less than that. So I'm also going to have to subtract 33, okay? All right, so here is where I ended up. I have 2x plus 5 squared equals 2x plus 1 squared plus 2x plus 3 squared minus 33. Now I got a bunch of math I got to do. And again, you should always be pausing me, trying this yourself, making sure you get the same answer, okay? Okay, so remember 2x plus 5 squared means 2x plus 5 times 2x plus 5. So the first thing I've done is I've taken all those squared binomials and I've just written them side by side each other so I can treat them as a little multiplication question. So when I have 2 binomials being multiplied together, I end up with 2x times 2x, which is 4x squared, 2x times 5, which is 10x, 5 times 2x, which is 10x, and 5 times 5, which is 25. Okay, so when I put that down there, I'm going to take those 2 middle terms right away and add them together. So that was 10x and 10x, so that'll give me 20x. Okay. Okay, over to the next section, I have 2x times 2x is 4x squared, 2x times 1 is 2x, 1 times 2x is 2x. I'll add those together, so 2x and 2x is 4x. Okay, and then 1 and times 1 is 1. Okay, and then the last one, 2x times 2x is 4x squared. 2x times 3 is 6. 3 times 2x is, sorry, 6x, I should have said there. 3 times 2x is 6x as well. So I'll add those two 6x's together to give me 12x. And then the last one there is 3 times 3 is 9. Okay, so that gives me this. Okay, don't shut down, you got this. Okay, so now I want to combine like terms on this side over here. So I've got 4x squared and 4x squared is 8x. Let me just show you what I'm looking at here. Okay, then I've got 4x and 12x, so that'll be 16x. And then I have 1 plus 9 is 10. and then subtract 33 would be negative 23. Okay. Now I'm going to bring these guys over to the other side. So essentially I'm going to subtract 4x from both sides. That's going to leave me with 8x squared minus 4x. So that'll be 4x squared. Sorry, 8x squared minus 4x squared, which will leave me with 4x squared. I'll subtract 20x from both sides. So that'll be 16x minus 20x, which will be negative 4x. And then I'll subtract 25 from both sides. Negative 23 subtract 25 is going to give me negative 48. So I'm at 0 equals 4x squared minus 4x minus 48. I could start thinking about factoring or the quadratic formula. I don't want to yet, though, because I see there's a 4 that's common to everything. Now, we always talk about factoring out the 4, right? If the 4 is the greatest common factor, you can factor it out. And that's totally true, but you get to work on both sides of an equation right now because the other side is 0. So what you can essentially do is say, I'm going to divide both sides by 4. Okay, well, 0 divided by 4 is still 0, but then what that leaves you with is just x squared minus x minus 12 on the other side. Okay, x squared minus x minus 12 on the other side. Okay, now I'm ready to factor. So I'm looking for two numbers that multiply together to give me negative 12 and add together to give me negative 1. They would be negative 4 and 3. So now I'm at the zero product principle. Either x minus 4 gives me my 0, or my x plus 3 will be my 0. If x minus 4 is my 0, then x equals 4. I just added 4 to both sides. And if x plus 3 equals 0, then I'm just subtracting 3 from both sides. Okay, so there are two different values for x, or two different solutions. I need to take that and put it back into what the three numbers are. Okay, so reminder, this is what represents my three numbers right now. So I need to plug 4 into x here, here, and here. So that would give me 8 plus 1. So that would give me 9, 11, and 13. Or if I plugged in negative 3 into there, that would give me 2 times negative 3, which is negative 6, plus 1 is negative 5. So that would give me negative 5, negative 3, and negative 1. So I actually have two solution sets here. And that's what I'll say in my conclusion. Okay, the three numbers are 9, 11, and 13, or negative 5, negative 3, and negative 1. And if you checked both of those sets, they both work fine. Okay, the square of the larger is equal to the square of the two smaller minus 33, or added together and then minus 33. Okay. All right, so that's where we're going to leave it today. You have some homework to do, you have some practice to do, and you have lots of questions to ask, okay? Please make sure you're asking me questions. I want to help you guys feel as good as possible around this stuff, okay? All right, so that's your task. For those of you who are following with me in school, this concludes this particular chapter. So we'll be doing some review and some assessments together. And then we will see you on the next video, which will begin our radical unit. So that'll be super fun. Okay. In the meantime, make sure you're practicing. Make sure you're doing lots of writing. Okay. It's when you're holding the pencil and you're actually letting that ink flow. I guess it's not ink with a pencil, but the graphite. I don't know what you say. You let flow, but that's how your brain makes the connections. Okay. So make sure you're taking the time to do that. Okay. And as always, ask me lots and lots of questions. You guys got this. Take care.